Welcome to this webinar recording brought to you by Vitec Energy. Dynamic simulations of a district heating grid. This is part of a previous webinar that was recorded in November 2019 with the title The Life Cycle of a District Heating Grid. If you would like to watch the full-size webinar, you could find it here in our YouTube channel at Vitec. I'm your host for today, and the speaker you will hear is Johan Dyrlind, our product owner of the solution called NetSim, which is a grid simulation software for district heating and district cooling purposes. If you would like to read more about the solution itself that is used in this presentation, you can go into our webpage and read more about it there. Now we will move on to Johan and the description of how to handle dynamic simulations for your district heating grid.
And we can evaluate operating condition for different things. And this, for example, would let us see what will happen with the grid in the summer, to see how should we operate the pumps, what temperatures should we use, and so on, to get a good working condition during the summer as well, or other lower load case scenarios. And NetSim also lets you change fast between these load cases. We can adapt to changes according to outdoor temperature. So we can set, for example, fixed supply temperatures that are dependent on the outdoor temperature. Both the return temperature and the heat load of each consumer can be connected to the outdoor temperature. So you can either group them to easily change all at once, or you can change them individually if you have different ways they react to change temperatures. And in the end, we have some time series calculations as well. And this is something you can do in NetSim as well, to see how your grid reacts with changes over time. So what you can do with this is specify social loads. And this is an example I have here on the left, where we have the power factor. So this is how much of our connected power we'll use at different hours. And it's a pretty standard way it looks during a typical 24-hour period of a weekday. So we have really low loads here in the early morning, with high loads when we get to the time when people actually get up and get to work, bit of a lower load for a while, and then another top when we get to the end of the day and people get home, and then we're dropping down again for the evening and night. So you can specify this. You can also see how temperature changes will impact things. If you change the supply temperature, what will happen in your grid? Either if you increase it, how long will it take for it to have an impact, and how what happens during the transition from one supply temperature to another. Also, if you have some problems and getting cold water into the grid, how will it spread through the grid, and how long does it take to recover from that? We also can see the travel time in the grid. So if you send out some temperature from the plant, how long will it take to reach the different consumers, and when will it impact them? So I have a test case here where we have the social loads. So I have a little video, and in this case we are looking at the differential pressures again. So I will just start this video, and as you can see in the top left here, we have the time, and we can see we have a fixed pressure out from the plant. So the red spreads further during the night, and then as we get to the morning, you can see that the blue side gets much bigger as we have an increased heat load. We need to push out more water, so it changes, and then we go back again to the night to have the red part spread a bit further. Yeah, we have the afternoon first, where we have another backing off period, and then going back into the night with pressure difference spreading out further through the grid. So this is something you can see on how the grid adapts to changes over time, and this is usually used for shorter periods, from maybe a few hours up until a couple of weeks or so, where you can see the changes that the grid does throughout as you change the loads or the temperatures. And that's it from me. I'm handing it back to our presenter today, to Johan.
Thank you to Johan Dyrlind at Vitec for that presentation. As said previously, if you would like to get more information, you could either go into our homepage or you can contact me with the contact details that you find in the description of this video. We have more videos in our YouTube channel, so please browse them and see if you find anything else that you think is suitable for your district heating need. Thank you very much and have a nice day.